Okay, guys, so we've been talking about Sig Figs, and what we're going to do now is we're going to work on y'all's rounding. You may think you know how to round, and maybe you do, but I know that not everyone is great at it, and there's some things that you need to avoid. I'm also going to teach you a brand new thing that has to do with the number 5 when you're rounding, so make sure you stay tuned for that. It's really important. So it's like this new crazy thing that you've never heard of when it comes to the number 5 and when you round. So let's get started. Okay, so there are 2 types of zeros that we don't consider significant. So just as a reminder, and this is on my board in the classroom, we never count leading zeros as being significant. So leading zeros are going to look like this or potentially like this, all right? So these would all be considered leading zeros right here, and these are never significant, okay? So those are not counted as significant figures. The other type are trailing zeros with no decimal in the number. So examples would be like the number 20. That's 0 without a decimal would mean that you are not going to count that 0. Now, also, or you could have the number like 99,000. These zeros would be trailing zeros with no decimal, so they do not count. So these type of zeros are what we call placeholder zeros. So they are holding, or they are maintaining place value in a number, so they are important, but they are not, they do not contribute to exactness or precision or certainty in a measurement. So for numbers 1 through 8, we're going to count the number of sig figs. So for number 1, this would be 4. This is a sandwich 0, so it counts. For number 2, we would only have 1 sig fig. This right here, these are leading zeros, so they do not count. For number 3, this would only be 2 sig figs. These do not count as they are trailing zeros with no decimal present. Now, if there was a decimal present behind that last 0, so if we had a decimal right here, then that would be 5 significant figures. But it is not, so that's only 2 sig figs, the 4 and the 5. Number 4, this is going to be 4 significant figures. This is a trailing 0 with a decimal present, so it does count. Number 5, that's going to be 4 sig figs. Number 6, this is 3 sig figs because of this decimal right here. Number 7, that's 5 significant figures. This is a sandwich 0. And then for number 8, that's going to be 4 sig figs. These are leading zeros. They do not count. These are trailing zeros with a decimal present, so they do count. Now, moving down here, we're going to do some practice with rounding off numbers. So we learned yesterday and earlier last week that there are operation rules. So there's these rules to rounding, okay? When you multiply or divide specifically, the rounding is based on the number of significant figures in the quantity that you start with. So you guys depends on the fewest sig figs in the measurements that you start with in your operation. So it's important that you guys know how to take a number with lots of significant figures and be able to reduce it, all right, properly. So right here in example A, it says round the quantity 34,928,000,000 picograms to show 4 sig figs, 3 sig figs, 2 sig figs, 1 sig fig. So we're going to take this value, this number, and we're going to, right now, it has 5 sig figs in it, right? But we want to write the number so that it only contains 4 sig figs, and then 3, and then 2, and then 1. All right, so right here, that means that if we want to keep 4 sig figs, that means we're going to keep the 3, which represents the 30 billion, 4, which represents 4 billion, the 9, which represents 900 million, and the 2, which represents 20 million, all right? That means that we're going to drop, that means that we cannot keep the 8. Now, here's the biggest mistake. This is what you should absolutely totally avoid. This is what I see students do. They're like, oh, I need to round this to 4 sig figs. 3, 4, 9, 3. 3,493 is not 34,928,000,000 rounded to 4 sig figs, okay? This is definitely not the rounded version of this very large value right here, okay? So recognize that you are keeping the 3, which represents 30 billion, the 4, which represents 4 billion, the 9, which represents 900 million, the 2 that represents 20 billion. Now, since there is an 8 that directly follows the 2, it will round up. So your answer rounded to 4 sig figs, that is, this measurement rounded to 4 sig figs, should be 3, 4, 9. The 2 rounds up to a 3, 0, 0, 0. So we're going to keep all these zeros because remember, these are trailing zeros without a decimal present. So they're not significant, but they are, as we've mentioned before, they're very important to holding the number's value, okay? So this now has 4 sig figs, but it is a rounded version of our original measurement with only 4 significant figures instead of 5. Now, in our next one, we are going to reduce this to 3 significant figures, okay? So when we reduce this to 3 significant figures, that means we get to keep the 3, the 4, and the 9. Now, the 2 is not enough to advance the 9. So this is just going to be 3, 4, 9, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so 34 billion, 900 million. So we get to keep the 30 billion. We get to keep the 4 billion. We get to keep the 900 million. But we are going to drop these 2 significant figures and just replace them with placeholder zeros. Now, for 2 sig figs, that means that we get to keep Now keep in mind, notice that I'm always going back to this original measurement every time. I'm not taking 2 sig figs and rounding this number right here, okay? I'm always going back to the original measurement, all right? So don't make that mistake when I give you these style of problems. We're always going back to the original measurement and using it to round. So if I'm going to keep 2 sig figs, that means I'm going to keep the 3 and the 4. The 9 will round up this 4 to a 5, so it'll be 35 billion. And then lastly, if you're going to reduce, and again, this is just practice so that when you are multiplying and dividing and say that you have to reduce your answer to 1 sig fig and you've got an answer like this that has 5 sig figs in it, you can't keep all 5. You have to reduce it. So if you have to reduce it to 4 sig figs, that means you only get to keep the 3, and the 3 represents 30 billion, so you're going to hold on to that. Now, here's the deal. This 3 is directly followed by a 4. I don't care what's down here, okay? The 4 is what dictates whether it rounds up. So remember, 4 and below means that you do not round your number up, okay? You guys should know this because a 92.4, right, is a B. It's a 92. Right? But a 92.5, okay, is a 93, all right? So, an A. Now, we'll talk more about that 5 in a second, all right? And how it applies to science and data and how we round with it. Now, so, you should notice that as we go through, as we had less and less sig figs, that as we reduce the number of significant figures, from here to here to here to here, all right, we were losing, you can see the number is losing its certainty, it's losing its exactness, but that's what happens when you have less sig figs involved. All right, let's move to this other one that's in a decimal form. So it says round the quantity 0.045740 kilometers to 4 sig figs, then 3, then 2, then 1. So how many sig figs do we have? Well, this is not significant, this is not significant. Okay, so these aren't sig figs, right? So we currently have 1, 2, 3, 4, 5. This is a trailing 0 in a decimal base number, so we currently have 5. We want to reduce this to 4 sig figs. So you want to keep these zeros. Do not get rid of your leading zeros. Just like we weren't getting rid of these, okay, because they're holding place value. Remember, these are not significant, so we want to keep those. Our first significant figure is right here, so we get to keep 1, 2, 3, 4. So that means we have to get rid of this, okay? We can't keep this 0 that is a significant digit, all right? So this is going to be 0.04574. Oops, 04574. All right, now we're going to keep, go back. Now we are only going to keep 3 sig figs. So this time we're going to be able to keep the 4, the 5, and just the 7. Now this 4 is not enough to round up the 7, so this would be 0.0457. And then 2 sig figs, that means that we're going to be able to keep the 4 and the 5, okay? So only the 4 and the 5. Now the 7 will round this up, so this is going to be 0.046. And then lastly, when we do 1 sig fig, remember I'm always going back to the original measurement, okay, to do my rounding. So this time I'm going to get to keep 1 sig fig, which means that I'm only going to keep my very first sig fig, which is going to be the 4. So I'm going to have 0.0, but this 4, the 5 will round up the 4. So this will be 0.05. Now, something that comes up every year at this time is students are like, well, up here you were putting zeros on behind the numbers. Why are you not putting zeros? Because if I put zeros behind these, that would be trailing zeros with a decimal present, okay? These zeros are very important to keep because they're going to keep your place value without affecting the sig fig count, okay? Over here, what's maintaining my place value in these examples is going to be those leading zeros. So notice how we're keeping these every time so that we're maintaining that place value, okay, that starts in the hundredths place with a significant digit. And then we're just slowly reducing the number of sig figs that follows that, that place value. So now it's time to talk about this crazy thing about the 5, okay? So basically, as I was saying earlier, you guys have always learned that if it's 4 or lower, that you do not round your number up, but if it's followed by 5 or higher, you do. Well, so here's the deal. There's actually a technicality to that, okay? So if you had 7.652, okay, and you needed to round this to 2 sig figs, okay? This is okay to round up. This 5 would round this up to 7.7, okay? Easy peasy, lemon squeezy, that's fine, all right? However, if you had 7.65, okay, and I said, okay, you need to round this to 2 sig figs, this 5 would not round it up. Here's why. If the number that you are trying to round, okay, is followed by what is known as an empty 5, I call these an empty 5. It is a 5 that has absolutely no other numbers behind it. There's nothing supporting it, right? There's nothing backing it up. It's just a lone 5, all right? Also, an empty 5 could also look like this. That is, if it's a 5 followed by a 0, that's also an empty 5. So if you're trying to round a number, okay, so let's say I'm trying to round this to 2 sig figs, all right, and this digit is followed by an empty 5, which can look like this or this. This is not an empty 5, okay? Right here, this 5 is actually followed by a digit, okay, which gives it support, which allows it to actually move this digit up, okay? Now, an empty 5 cannot advance an even digit. So see how this 6 is an even digit, all right? So technically, this would have to remain 7.6 in both of these cases. However, if it is if that 6 has a 5 that is supported, that is, it has a 1 through 9 digit following it, you can round it up. I know this is weird because it's brand new, okay? But just follow me. I'm going to do a couple of examples with you. So here is the new crazy thing that you didn't know about the 5, okay? All right, if the digit to be removed or replaced is 5, followed by 0 or nothing, and the preceding digit is odd, go ahead and raise that digit. If the digit to be removed or replaced is a 5 followed by 0 or nothing, and the preceding digit is even, the preceding digit remains unchanged. So over here, this is an even number, okay? This is the number I'm trying to decide whether I can round it up or not. If it is because it is even, if it is followed by what is known as an empty 5, okay? If it is followed by an empty 5, and both of these are what we call empty 5s, then I cannot round it up. It would be 7.6 in both cases. Now, if it's an even number and it's followed by some number here that's 1 through 9, sure, go ahead and round it up, business as usual. Now, if it's an odd number, so let's say it's 350 or 7.35. This right here is, and we need 2 Sig Figs. This is an odd number. Odd digits doesn't matter. Odd digits can round up with an empty 5, okay? Everybody's like, why? That's so weird, Miss Wood. Why is it that evens don't get to, but odds do? Well, my thinking on that is, and of course I don't know this for sure, but my thinking is when you go 1, 2, 3, 4, 5, 6, 7, 8, 9, before you get to 10, okay, the closest number before you go up to the next place value is a 9, which is odd. So my thought is that because 9 is an odd number, that all odd numbers get to advance up. Again, this is just me. I don't really know that that's true, but it gets to round up. Evens don't, okay? So 7.35, this 5, even though these are both what we call empty 5s, that is, it's followed by nothing or a 0, they could actually round up to 7.4 in both cases, all right? So really all you're having to remember is that a 5, up to this point, y'all have known that a 5 always allows you to round up. So basically all you need to remember is the only time a 5 cannot round up a digit is if it is an empty 5 that is following an even digit, okay? So if you have an even digit you're trying to round up and it's followed by an empty 5, you cannot round it up with 5. Everything else can round up with a 5. So let's look at these. So you've got this, and you want to round to 2 Sig Figs. Well, this is an empty 5. It's followed by zeros. However, this is a 3, which is odd, okay? So it can advance upward. It can go to a 4 with an empty 5, okay? Because it's odd. Right here, I've got a 9 and a 7, okay? This is also an empty 5 because it's followed by nothing. And I want 2 Sig Figs, right? 2. So this can round up to 98. Business as usual. Everything y'all are used to. Now, we go down to these 2 examples. You've got 76.5. You've got an empty 5 right here. An empty 5, again, is followed by 0 or nothing. It has no support behind it. This is going to be 76. I cannot round up with this. Now, if this was 76.51, I could round up to 77. Because that is not an empty 5. It's followed by some sort of other digit that supports it, that gives it more value. All right, and so the only other one I have left is this example. We want only 2. We're rounding to 2 Sig Figs. Okay, this is just because I'm asking you guys to do it. So we want to keep the 1 million and we want to keep the 600,000. This right here is an empty 5, okay? Because it's followed by zeros, no support, okay? So because of that, that's an empty 5. And because 6 is an even digit, we cannot round it up. So this is just going to be 1,600,000, okay? So that's going to be 2 Sig Figs, all right? So the new crazy thing about the 5, just remember, A 5 can always round up. It always has. The only instance is if it's an even digit you're trying to round, followed by an empty 5, okay? And that's it. We'll do some practice on this today and get you guys rolling.